We want to express this complex number in modulus argument form. So we need to find the modulus, r, and the argument, theta, in order to do that. So the first thing that I would recommend doing is drawing a sketch of the Argand diagram and labelling or plotting your complex number. So we've got a real part of -1 and an imaginary part, the coefficient of I is -1. So we've got that coordinate in the Argand diagram. So we can find out what r is. Remember, r is the modulus of the complex number, or the distance of the complex number away from the origin. So r is going to be equal to, well, if we draw in a right angle triangle, then we can just use Pythagoras to work out that length r. This length on the right angle triangle is 1, and this length is also 1. So we can just say that r is equal to the square root of 1 squared plus 1 squared, which is √2. We also need to find theta, which is the argument of the complex number z. So there's a few ways to do this. What we could do, well, let's just think about what the argument is. Remember, we measure the argument from the positive real axis, so that green line there. So we basically want to know what is that angle there. Now notice that we're using the principal argument because here it says theta has to be in between -pi and pi. So what we're not allowed to do is we're not allowed to spin around in the positive direction, because then we would have to spin around an angle greater than pi. So we need to spin around in the negative direction, and that's going to be that green angle there, but in the negative direction. So the way that I'm going to find that angle is I'm going to find this angle first, which I'm going to call alpha. So using this right angle triangle that I drew, I know that tan alpha is equal to opposite divided by the adjacent. So if I work out what alpha is pi/4. So then I know that this green angle here is going to be pi minus pi/4, which is 3pi/4. So I know that theta, therefore, the argument of z, which we're calling theta, is going to be equal to minus 3pi/4. That's because I've moved in the negative direction by an angle of 3pi/4. So then that means that we can express z -1 minus I as r, so √2 cos of minus 3pi/4 plus I sine of minus 3pi/4. And the way that you can check this works is just check that if you expand this out, then you get the real part and the imaginary part correct. So the real part, we want to check that -1 is equal to √2 times cos of minus 3pi/4, which it is. And we want to check that the coefficient of I is correct on the right hand side. So we want to check that -1 is equal to √2 sine of minus 3pi/4, which it is. So we've got the real part correct and the imaginary part correct.